Hello, this is continued from the previous video. In the previous video, I introduced the summarize command, which is really useful. And also, I showed you how to use if option and by option. I will give you a simple tip. Actually, by option can be simplified to by sort. So almost always by and sort goes together. So this is how usually use. So same thing, same command, but simplified into one command, by sort. But it does not matter. Both are doing the same thing. I'm just telling you. And we are going to, in this video, we are going to regress the birth weight on smoking. So regression is here, here. Regression, dependent variable is birth weight. Independent variable is smoking. And then click OK. So if you click OK, you get the results and you know how to interpret this. First, you have 3,000 observations, which is quite a few. And then, according to this estimation, smoker, if a mother smokes during her pregnancy, then the baby's birth weight drops by 253 grams, which is about half pound. Um, and usually baby birth weight is an important measure of baby's health. The heavier, the better, almost always. So keep that in mind. And what's interesting here is this number this number equals to the difference between this and this. If you use calculator and find the difference between these two numbers, two group-wise means, to group-by-group means, then you are going to get this one. So basically, the regression is calculating the difference between group means. So you can verify that by simple calculus. And also, what's interesting here is the intercept is this guy. I explained this in the lecture earlier. This intercept is the value of y when x equals to 0. So when x equals to 0, y is on average this. So they must be the same. And what else? So we have standard errors, and based on the standard errors and the coefficient estimates, you can find t statistic, p-value, and confidence interval. I believe you can interpret them. Also, we have sum of squares. So model sum of squares, residual sum of squares, total sum of squares. The numbers are huge because there are 3,000 observations. So here it is 1.0516. E plus 09 means 10 to the exponent of 9. So you have to put 9 zeros from here. So the summation is a huge number as the sample size is large. And these guys are not important by themselves, but by considering their ratio, we have a square. So smoking determines about 2.8% of baby's birth weight variation. So 2.8%, like approximately 3% of baby's birth weight can be explained by the mother's smoking behavior. And also this is root mean squared error, which is called the standard error of the regression, is 583, which is very similar, somewhere in between these two guys. So it's close. It's not exactly the same, but closely related to this and this. So they are related. And this is how we interpret the regression result. And what we are going to do from now is that we will use the robust standard error formula. From now on, you are going to use the option almost always. Whenever you run a regression, I recommend you to use the option. So same dependent variable, same independent variable. Now I'm going to use this option. Standard error and robust option. If you click here, you have options. The default is homoscedasticity standard errors, but we are going to use robust. Just use the default and click OK. And there are other options, but you don't need to know them at the moment. OK, then you get a different result. So this much is the robust standard error formula option. So VCE means variance and covariance estimator, I believe. The variance and covariance estimator is calculated according to robust standard error option. And a clear difference is that this area is empty. Sum of squared errors, sum of squared residuals, or sum of squares now have no clear meaning without homoscedasticity, because in a group, the residuals are larger, but in another group, the residuals are smaller. So when you add these two different residuals, then it's kind of unfair. You are kind of using this group much more than this group. So sum of squares anyhow themselves are not important, but we still have the same R squares. The R squared is the same as before, which means the formula does not change. So the R squared formula is not affected by the homoscedasticity assumption. So without that assumption, still the formula is the same. And root mean squared error is also the same. Root mean squared error formula does not depend on the homoscedasticity assumption. And going back to the coefficient, as you see, coefficients are also the same. It does not depend on the coefficient does not depend on the homoscedasticity assumption. And I explained they are coming from simple averages. So the averages have nothing to do with their variances. So not a big surprise. But this part is the difference. The difference, as you can see, the difference is pretty small. So with robust standard error formula, you get a similar result as before, which means it looks like the homoscedasticity assumption is correct. So with or without the homoscedasticity assumption, anyhow, you are going to get a similar assumption. So in this case, it's not a big change, but still, then why not use a robust one? If they are similar, I would take this one, right? And also, I said earlier that homoscedasticity assumption is likely to hold because these two guys are similar. The standard deviation is pretty much similar across different groups, so implying a homoscedasticity assumption. So this is homework number 2. What you need to do here is you can collect the commands you use and make a do file. Always use a do file. If you are familiar with the commands, you can directly start from the do file like this, but at the beginning. So when you first learn Stata, I encourage you to use this one. And what you need here is this. So these commands are what you need. And regression. And another regression. So this is what we do in the homework 2. So good luck and see you next week. Bye.